we're engineers. We're all engineers, and the AI engineers see everything as a nail because they've got this lovely little hammer as a large language model, and they want to bang, even the workflow issues and the complex problems in the workplace with a large language model solution. Yes, the large language model has a part to play, but as a component of the existing automation that we have. But that existing automation, the way we've been writing the code, is not ready to absorb this LLM. We need to change that automation the way we actually construct it, and we flip it on its head.
You're listening to The AI Optimist with Declan Dunn.
You just heard somebody who's talking about AI in a very different way. His name is Massoud Alibakhsh, CEO of Omadeus.com, Omadeus. And we're talking about how AI frees your time, how intelligent objects and workflows cut 20 to 40% of workday waste. His desire is really to find a solution to the communication problem between people and the systems they use. And in the AI market, everyone's talking about the tech as a tool, but not a platform. And in doing so, he's putting AI into project management and really a paradigm shift. Let's take a listen. How did he come up with the original idea like Amadeus?
So we used to use a product called Jira to manage one part of the group. And then we use Trello and Slack and Asana and for different purposes, because each tool provides something specific. It solves part of the problem. And we wrote a program to connect all these things together, and it was always falling apart, breaking. And so as a technologist, entrepreneur, CEO, my ideal, what I had in my mind as in what would work ideally, I saw that this model can resolve this issue. So we decided to create a product, a project management tool for technology companies that solves this problem in a beautiful way. And that's the name of the product, Amadeus, because essentially it's about conducting the flow of information, which is done intelligently in a harmonious way. So it kind of resonates with symphony and melody and beautiful harmonies. So everything moves in a harmonious way inside our product, Amadeus.
What a fascinating approach. But isn't this just another AI to replace people? That's what I wanted to ask him next. How do you get like those issues of making sure that this augments the person, what they're doing? Because I can see them sort of knee-jerking and thinking that they would be replaced because your current system, I don't see what you're doing as replacing them. But you understand if something's new and somebody's like, wait, is that a challenge to me? Do I stay in control of the information?
No, AI is going to finally fulfill the promise of automation and rid humans from these mundane, mind-killing, crazy things that we do on a daily basis and that are boring and we call work.
Right.
I mean, and you can pick any. I mean, you have an interesting job. I mean, there are exceptions. Like I have a wonderful job because I follow my passion. I'm an engineer. I discover things. I'm constantly learning. You're constantly talking to people. Some interesting, some boring. But most people, and I've been there. As I had 9-to-5 jobs where I punched in, punched out, and I've done all kinds of work in my life as a student. I paid my way to pay for my school. I was a waiter. I pumped gas. I cleaned places. I built roofs. And actually those were interesting jobs. But I had a lot of boring stuff that they call work just to make a living. And a majority of people are doing that on a daily basis, and they're bored to death. And I think AI is going to create an opportunity where humans get to be humans. We all have God-given gifts. We don't get a chance to explore them. Every single one of us, every single one. I mean, I don't care who you are, you have a gift. And you just have been thrown into this wild system we call the capitalism and market driven forces compel us to be scared for our survival, so we can seek something that basically guarantees our roof over our head and our health. And we convince ourselves that, okay, I don't know, I am XYZ, but on a daily basis I go there and deal with bosses I don't like, that really don't treat me with respect, and things that I do on a daily basis is routine, mundane stuff. That's not for humans. But we convince ourselves, and we kind of, some of us may be good at it, and some of us may even like it, but it's very rare, and AI is going to get rid of all that. Hopefully it's going to improve that situation. But the kind of stuff we're working on is really quite interesting, because I come at it from the angle of automations in the workplace. And my background as an engineer kind of drove me to discover and invent some of these tools that we've created, and I can get into this.
I love the fact that he sees AI as empowering people, and using this as a platform is a little hard to wrap my head around. And it struck me that the new GPTs from ChatGPT hold such promise, but ended up creating more complexity. Like, how many of these AI pieces can we manage? How do we work together? It was funny because when you're saying with like ChatGPT, they just came out, OpenAI just came out this week with create your own GPT, and you don't need to do coding, and it's fun, and I've been playing with it. But to your point, a lot, it just ends up creating more spokes. Like, I'll solve this and I'll solve that. I'm not saying anything against it. More, it was sort of interesting that it still relies on me to figure out where I can put this in the workflow, where the workflow needs to be more intelligent and help me how to make the workflows more efficient that inherently aren't, I wouldn't say they're not efficient, but we have habits. This is what we had.
But you said it. You use a great word just now, intelligent workflow. That's a brilliant way of putting it. That's yes, we're making our workflows intelligent. Exactly. You just said it as you were kind of assessing this. It is. And if you think about it, see, what the discovery of object messaging is, AI is part of it. AI is only one part of it. But the real fundamental part is that when you get together, humans, when they come together and aggregate it in what we call companies, we come together and we make things, right? And then we mass produce them, thanks to the invention of the assembly line, and we abstracted that and we call it workflow. And workflow is actually more complex than straight assembly lines, because they're multidimensional, because they're virtual. You can create all kinds of crazy workflows that if you were to create them in reality, you couldn't, because it's a 5-dimensional thing. Here it goes, the form I fill out section, I give it to you. You decide, oh, this needs to go upstairs, or no, this one goes downstairs, or this goes to the office next door. So you could route them in different ways, and the same thing. So that the workflow is much more complex. But we humans, in order to do our work collectively, we need to communicate. And so these workflows are nervous systems that are really wiring these neurons of this organization. If you imagine the humans are the neurons, the actual creative elements that generate energy, generate information, and consume information. And this nervous system is connecting all these people together. And we also walk to each other and sit there and face to face, and we exchange information. This we do some of this stuff as well. In meetings, and take notes and hand sticky notes. But the majority of the information is what's in the system, right? And these systems, the way they communicate needs to change.
Man, it's easy to see we need to change systems and people's perception of AI as a tool and into AI as a platform. But let the engineer describe this paradigm-shifting invention called Omadeus, and walk you through an example of how an X-ray can actually be intelligent.
Now we can shift to the invention that the system that we've created.
Yeah.
And that's a very interesting problem, because if you look at large language models, which ChatGPT is a large language model, they basically are like a vacuum cleaner. They turned it on and they put it on the internet, and it sucked all the words, essentially, and it condensed it, and it squeezed it, and it made it into some sort of a knowledge ball. And I tell my friends not to get upset with whenever they're interacting with these LLMs. I mean, ChatGPT is one, but you have Claude AI, you have a few different competitors. People project their own humanity on the machine. And I tell them, don't get upset with it. And you can argue with it and play and use it as a tool. It's wonderful. They do wonderful things. But don't project your humanity onto it, because there's nothing more than a word calculator. I mean, like calculator, you put in numbers and you press functions and it spits out numbers. I mean, just think about it. You put in, and they're cheap. You can buy them for a few pennies now, right? But they're extreme. If you take that back to a few hundred years ago, people would think that came from the sky, right? Here's this magical tool that it knows, it can multiply faster than any human. But ChatGPT or LLMs are, the input is words and the output is words. And the functions are not written on there, plus minus. The functions are also words. So you use words to tell it what to do. So you got it. So that's what they call the prompt engineering. That's all it is. And it does very interesting stuff. You can load it with a document, and it can read and understand, and you can ask questions about that document. You can tell it to summarize the document. A lot of teenagers discovered ChatGPT early on, and got a lot of help with a lot of homework, caused a lot of problems for a lot of teachers. And that's really how it burst onto the scene. Yeah. And it's being applied in businesses all over the place for all kinds of problems, mostly really for support, chatbots, because it's very effective for that. If you kind of constrain the domain and feed it some information, then you can ask it questions. It's very intelligent. You can even tie it to a database and give it some numbers. I love using them. I recently had to change my glasses. I was so happy using, because I could see that the technology has improved. It knew my sales orders, because I could see that not only it processes the language, it's also connected to the database, and it can look up invoices and can read them. But that's really that's the limit to these tools. That's it. We can really not go further out, much further out. And the fundamental problem that we're dealing with at work is that humans, we come together and we create these organizations we call companies, and we get organized around this virtual assembly line, which is called workflow, and we produce things. Because I'm an engineer, entrepreneur, and this is my third technology startup. And when you start a company, at first when you're just by yourself, it's easy because you don't have to communicate with anyone. You're super efficient. You're super efficient. But as soon as you have one more person, and the second, third, it's okay. You can handle that because even email can exchange information between a few people. But as soon as you start adding more and more people, the whole thing starts breaking down. Everything starts slowing down. And you're adding people because you're successful, because your product does something and people like it and you're selling it. So you need salespeople, you're marketing, you need more people to make more products and expand it and add features. And by the time you're not 20, 30 people, you have a mess on your hand. Yeah. Because, and to me, I was so curious to solve this problem. And it was intuitively obvious to me that the problem is communication. And most people understand that. Most people know that the problem is communication. But how to solve it, where to start? We don't believe that GPT technology is going to get there. It's not going to get us there. What's going to get us there, and this is the architecture that we've introduced, and we've already built a system using that architecture to kind of demonstrate this is how you build these intelligent systems, and it's inspired from biology. So if you imagine humans around this nervous system, and we create this beehive, and this is think of it as a biological entity, and the nervous system is the workflow, and humans are connected to this workflow as the intelligent agents. We have the will, we have the awareness of what we want to make, and we all have expertise. I have a good taste in color, for example. I think, or you have creativity in designing a better transistor or an amplifier, or how things need to. But you also use tools, but we're connected to this network, and we're communicating with each other. But the problem is that the exchange of information, the tools that we're using, is reliant on individuals. And individuals, humans we're not good at exchanging information for the reasons that I mentioned, because the tools that we've created, they are flawed in their model, whether it's a system that you put a bunch of numbers in and you hit save, and then you go and put an email. All this stuff needs to merge. The silos in the channels, the email information, the sticky notes, the stuff data I put on the screen, they need to converge. And the architecture that we propose is inspired from biology. Look, we're saying, look, you get to the system designer, do your original analysis, find the workflow, document the workflow. That's how traditionally we build systems. Take those forms from the users, analyze the data, but go further, do some semantic analysis, and identify the objects in that environment. And these objects or entities, what we call critical entities, are the smallest components that humans talk about. And so if you're making radio, the smallest component could be a resistor or a transistor. So each one these are all critical entities, because you put them together to make an amplifier. And that becomes a supercomponent. And a supercomponent, that entity is like your liver, but that supercomponent is also aware of itself. So we make these components responsible for themselves, for keeping track of information about themselves, and figuring out who their stakeholders are. So it's these objects that become intelligent. And now the way we make them intelligent is we give them the structured data. For example, let's say we're in a doctor's office, and I'm a technician who takes an X-ray. So I take your X-ray, a chest X-ray, and then I create that object inside the computer, and I say, well, this is an X-ray of James, and this is his age, and this is a chest X-ray. So this is tradition. This is what we do already. So this is the structured information that gets attached to that X-ray. Now we can build logic and traditional logic as to give this X-ray programming to help it to navigate through workflow. But we also give it a large language model. We attach a large language model to this object. Now, this large language model can read all this structured data and can also interact with me as a human using natural language. Because now I made that X-ray capable of interacting with me as a human using natural language. But I also give that X-ray a bunch of different diary books. I give it a black diary so it can keep track of the dialogues between me and itself and the doctor and the nurse, because that black book is special. It just puts all the information that's related for us. And I give it a green book because it wants to keep track of the dialogue between the doctor, the nurse, and the patient, because I'm the X-ray person. I don't need to see that. So basically the object becomes aware of what it is, because now it knows it's an X-ray, because it has a large language model, it has AI. It gains self-awareness as to what it is. And it's programmed to know how to navigate the workflow. For example, it's programmed to know that as soon as it's taken, what you should do, you should go to this address over the internet, and here's your authentication, here's your passcode, and you go over the internet to Mayo Clinic's database, and they've got this other model that is designed to read X-rays of your type, feed yourself to it, that produces a report in natural language. Take the report, read it, and understand it. And if you've got any major issues, immediately report to Dr. Smith or whoever your primary doctor is. Okay, so you can make that today. We can actually create that today, right? Everything that I explained. A combination of traditional programming and adding the LLM, using this new architecture that we are proposing. Identify the object, create these channels, different channels that I call the diary books for different classes of stakeholders to maintain the information about itself. And that information includes the dialogue with each other. So if I, as the technician, I'm talking to you, the doctor, about the X-ray is present, is listening, and it's actually recording all of our dialogue in its black book. I say something in the black book, you respond to me in the black book, and every time I put something in the black book, the X-ray shows up in your inbox and says, hey, here's what Massoud said. Here, it opens up the book and you can read it.
Yeah.
And then you say something in it. So that's how the X-ray keeps track of us as stakeholders, and it bounces around and it's intelligent. It knows that, okay, now I got to go and hit myself against this model that reads X-rays in Mayo Clinic, and I just read it and go, oh God, I'm cancerous. I got to run over and show myself to Dr. Smith. X-ray is, and this is what we call object messaging. Our model is called object messaging and intelligent objects. Right. And so the object itself is intelligent, and it carries all the information about itself, and it presents itself during the process of moving around in the workflow, interacting with other objects and interacting with other humans. Depending on what happens, it records those events in natural language in the right channel, and it presents itself to the right stakeholder at the right time. Critical key points, the things that humans are not good at. Delivering information to the right person at the right time. Okay, because that right time has something to do with the tempo of the workflow. That's the heartbeat of the organization, that the whole machine needs to be moving with that tempo. And each object has its own heartbeat in a sense, right? As moving around. So the X-ray as a component belongs to, as a small object, belongs to a whole series of things. It belongs to a visit, that's a super component, that contains its sister, which is a blood test that was ordered by the doctor, right? Or some other exam. And the actual, primary exam, the taking of your blood pressure and your vitals that the nurse did initially, that itself is a super component. Each one of those, the measurement of your heartbeat, the measurement of your temperature is actually an intelligent object. And together they create the vital supercomponent. And that supercomponent vital is itself an object. And it has an awareness about itself. So at one point, the doctor, and they all have the LLM that they can have interact with the stakeholders, humans, but they can also interact with each other using natural language. So, and if you think about this system that is composed of lots of intelligent objects, organizing these hierarchical fashions in a way, but around the workflow as they're moving around and interacting with humans. So it's the object that knows that, God, I got to run over and show myself to Massoud and say, hey, look, I'm cancerous. So it shows up you're the primary doctor, says, look, I just got this report, and here are the highlights of what you need to look at. And by the way, here's the report, because you didn't put it in some file folder and somebody emailed it to you. I'm carrying it. I'm the X-ray. This is information about me. I'm holding it. And I can show you whatever you want. By the way, I can show you the whole report, or you can just ask me questions because I read the report. And I can tell you the important stuff. And you got to look here, look here, look here, and look here. And by the way, because you're the primary doctor, I have identified a specialist who lives in South Africa and is on the system. And I negotiated with his appointment object. In 2 minutes, we're going to have a conference call, and I'm going to connect you guys. And boom, here, connecting you. Now you guys having a conference call just like this that you and I are doing. And guess what? The X-ray is sitting there listening. Why? Because it can understand the language. And you guys can talk about it. And it also read the report. It can even have an opinion and say, well, I understand, Dr. Smith, you're saying this, but the model at Mayo Clinic said this about me, so I'd like to highlight that area. So you have 3 doctors all having conversations here. So the X-ray itself is also a stakeholder in this, because it has intelligence about itself. And all this information, the dialogue, the video is all captured at the end. You don't need to save it in some file folder. Don't worry about it. The X-ray will hold that too. And in fact, I've read it and I've known everything about it. And 2 months later, when I show up in your inbox for some other reason, if you don't recognize me, you ask me, say, well, what are you doing in my inbox? And so you don't remember me? You talked to Dr. Smith about me, and this is what you said. Would you like to see that 10 seconds of the video? Here it is. This is what you said. And this is what he said. Oh, really? So you can interact with it like an intelligent object or intelligent entity and query it. And so, and that object itself knows that it's part of a whole visit and it belongs to this patient. And so when you decide to talk to the patient, it says, okay, well, I'm going to, by the way, I've also negotiated and sent an urgent appointment request with my patient for which I belong to that patient. So you can have a dialogue with Mrs. Smith about me. But remember, these are the new HIPAA rules that were passed, and these are the things that you need. These are the guidelines that you need to follow. I just read them. They were published 5 minutes ago, but I just read them. So here I could tell you what to say, what not to say, right? So just imagine that so all the information about these objects end up at the right place, right time. So we don't need to figure out where to organize this stuff, which file folder to put them, who to send them to. That is what we call object messaging, an intelligent object. And it's an architecture that we're proposing that merges the new LLM, this form of AI, with traditional software systems, but with a new architecture altogether.
Wow, so many layers to that too. But it's interesting because one of the things I thought, just using your X-ray analogy, the X-ray old ways is an output that sits around and somebody's memory has to be able to process it and hand it around, maybe the facilitator, maybe the doctor, but making the actual data, the actual output, intelligent of its place in our integrated system platform, that it knows, and it knows to look and communicate, and it's actually being an active participant. And so it's not like data is so considered past, right? And
very well put. Very well put. It's no longer data. The X-ray is an intelligent entity, and you can think of the notion of an X-ray. The actual film is just data, is one of its attributes. There is an intelligent, a virtual object that's intelligent that knows that this film is just part of me, but I'm an X-ray. So you've given some form of awareness there that is a combination of large language model and traditional algorithms along the structured data that you're an X-ray, you're a chest X-ray, you belong to a 65-year-old Susie Q. And actually this is, by the way, this is her blood test, So, and in fact, the combination of all these components and super components can be controlled by a higher level brain. So if I go back to the example of the mobile phone, right? So if you imagine, and this is actually a new paper I'm writing about the AI-based operating systems, such that there's an LLM in front. I mean, right now you have Siri and Google Talk or whatever they call it. And most people who've used it, I don't know of anyone who uses it because they're stupid. They're dumb because they don't really have access to information because they're pre-programmed with some hard-coded stuff. They know some things about the weather. They've been loaded up with some, but they don't know anything about my Bank of America app. They can't access that. Right. They can't go in there and click in there and figure out how to navigate in there and look up my balance and see how much I've budgeted for my lunch today. Or they can't access my diet program or my fasting program. It can't access any of the other programs. It's not connected to any of those. And even if it was connected, it couldn't really communicate with the current model. But imagine every single app on this device is written using object messaging and intelligent objects, such that the actual app, you can interact with it using natural language. And then you put a higher level brain on top of this, and the user just talks to the big brain and talks to the computer, and that big brain decides and deciphers, saying for that, he's hungry. Okay, let me first talk to the diet program and get what his situation is there. Okay, he had fish yesterday. Okay, the diet program says he should have chicken. Okay, I'll take that. Well, let me talk now to can we afford this? What can I get him? Let me talk to the Bank of America app, see what we got there as a budget, right? Like, right. Okay, so bang, here it is. What do we got in our budget? This is what you've got for lunch today, $15. Okay, now let me see what I can get with $15 chicken. Oh, here's his location. So this is all AI stuff, right? Okay, I found 3 different things. Let me display that on his screen. Here it is, right? Okay, and then Massoud says, I don't like any of this stuff. Give me something fancier. Right. Says, well, we can't afford anything fancier. It's already got all the information, you see? So this kind of architecture that I'm describing can make possible what you saw in that movie, Her. ChatGPT type of AI, these large language models, I don't care how many more parameters you feed them. I don't care how much more tuning you do. I don't care how much more computing you throw at them. Version 5.0, 6.0, 7.0, with this current architecture, they're not going to be able to give you what I described. And in fact, my argument is, why go there? We can actually show already an existing architecture that can deliver this. And by the way, the output of these LLMs are not all that reliable, because right. they call that hallucination. And then so you're aware of that. And so the part that's reliable is the processing of the natural language. Because even when it hallucinates, which is euphemistically referred to as hallucination, the Google people call it that. I call it confident bullshitting. It's okay. Quite confident. And I mean, if you've ever seen it, it's amazing. And I've known quite a number of insurance salespeople who use the same. They hallucinate.
The 2-step,
yeah. So that's not really reliable. And so I tell some of my friend engineers, like, would you allow ChatGPT's output to fly your plane or drive your car? No. Because it hallucinates, right? So when you build a system, engineers like to have a reliability. When we build a plane that's going to cross the Atlantic, we put 2 engines on it, both for load balancing. They're both working, and also what we call fault tolerance.
Right.
If one breaks down, the other one still can get you home, right? So, and these are critical things we're doing in operations we're doing in saving patients and building systems, managing nuclear stations. Most of the stuff we do at work, they're critical. They're mission critical, they're referred to as. And you can't have the output of ChatGPT or the output of these systems drive that. So you need a combination of deterministic logic, the traditional enterprise software, with a new approach, a new architecture that we've proposed, I refer to in my paper as object messaging and intelligent object that I described. And you take the natural language capabilities of AI and combine them in this way, and voila, you have a beautiful system that is intelligent. And you can build that today.
The AI Optimist.
My name's Declan, and I'm done. See you next time.